Hello, my name is Carson Grosbeck, and this is Building Information Modeling and Management and its applications in modern architecture and construction. Building information modeling is a revolutionary technology that is transforming the way modern architecture is designed and constructed. In essence, it is a digital representation of a building that includes all of its physical and functional characteristics. This includes everything from the walls, floors, and ceilings to the plumbing, electrical, and HVAC systems. Applications of building information modeling are vast and varied. One of the significant benefits is that it allows architects and engineers to visualize and simulate a building before it is constructed. This can help identify potential problems and eliminate them before they become costly mistakes. Another application of BIM modeling is that it can improve communication and collaboration between different stakeholders involved in the construction process. This includes architects, engineers, contractors, and building owners. By having all the information in one place, it is easier to share and access, which can lead to better decision making. What is BIM? BIM is a digital representation of physical parts of a building or function. It stores the progress of a project for better cooperation throughout one individual project. BIM is often 3D models that consist of geometry, relations, and attributes of a construction project. There are different types of BIM models that include 3D BIM, which is a simple 3D model consisting of height, width, and depth. 4D BIM, which includes physical attributes of a model, but also the time needed to complete differing parts of the project. And lastly, 5D BIM, which includes the cost, asset management, and material sustainability of a project. BIM covers more than just the geometry, though. It also covers the spatial relationships, geospatial information, quantities, and properties of building components. For example, like manufacturing details for different products. And it also enables a wide range of collaborative processes relating to the built asset, from initial planning to the construction and throughout its entire operational life. BIM applications, such as Autodesk's Revit, allow different views of a building model for drawing production and other uses. These different views are automatically consistent, being based on a single definition of each object instance. BIM modeling software also defines its parameters and relations to other objects, so that if a related object is changed, ones around it will automatically also change with it. Almost every department of a construction project, from lead architects to the landscapers, are included in the design process. Each professional adds their own specific data to the project to make it as accurate as it possibly can for more efficiency and cost prediction. What are BIM models' usage? The use of 3D models goes beyond the initial design and planning part of the construction project, but it also has benefits in the cost and construction management, because construction teams can use the models to basically see if they are completing a project in the way as it is designed, without making mistakes or flaws in the initial planning. And when a completed model has all the required construction elements needed to complete it, the users can predict the cost of material needed to finish a project all the way through the entire thing. Throughout the process of a project, a building information model is used and can be changed throughout its entire life of its process. Because of this, a BIM manager would be used to ensure the design and the project stay consistent. Because of the severity of detail on a model, different companies sometimes have entire teams of managers or overseers to stay working on the same project. The benefits of using BIM in the design phase. During the process of a project, an architect must take into consideration the cost, schedule, and project scope. Changes to any one of these can lead to hindering a project because of the time that goes into needing to integrate the change into a design. When using a modeling program, these changes are instantaneous, meaning whenever a change is made, it is instantly applied to the design and therefore saves time throughout the entire progress of the project. Whenever the change is made, the consequences of that change are coordinated throughout the entirety of the project. Because of this, a design team can devote more time to improving the quality of the project, and makes the workflow much faster because the coordination eliminates the need for manually checking the work of others and making sure the timeline of a project is in order and nothing is missing from that workflow flow. The coordination of effort in effect eliminates mistakes because of miscommunication on the design. It improves the quality of the work and helps with repetitive business on certain projects. The benefits of using BIM during the construction phase. BIM makes concurrent information readily available for any workers to see building quality, what the schedule is, and what something specific is supposed to cost. Because of this, the speed at which projects are completed efficiently and correctly is higher. Also, because of the cooperation of workers and designers, both can see what is needed for renovation based on unforeseen impacts on the project. For example, missing materials or not enough personnel. They can quickly communicate these needs to resolve them, saving time, money, and resources in the long run. For my interview, I interviewed my architecture teacher at the local high school about what BIM is and its applications in architecture. A lot of what we talked about are the benefits of using it and how it's so easy to use rather than its alternative of physical paper drawings. And we also talked about modern examples of BIM projects, including locally a place called Autoval, which uses BIM and robotics to create apartment modulars, as well as a project in the city of Dubai where BIM is implemented in almost every step, as it was a very large project that needed all sorts of cooperation throughout its entirety. For my observations, I sat in through a class lesson at the local high school. For the first day, we worked on creating a 2D floor plan using the Revit program by AutoCAD mentioned earlier. The teacher had everyone work on different house models, so each one was unique according to the student who designed it. For the second day, we used that 2D floor plan we created the first day to build a completely fleshed out 3D model. For the third day, we continued to work on our own design for that 3D model, and some students, including myself, helped others who didn't quite understand it. For the fourth day, the next steps in the design process, we went through how to accurately render a model inside the program. For the fifth day, the teacher gave us a work day, so we were able to either help each other or work on anything we were behind on. For the sixth day, the teacher came around and checked every student's model to see their progress and to grade how they were doing. What did I learn through these observations? Well, throughout the class, I spent sitting in on the lesson on how to model a house in Revit AutoCAD. Throughout the class on how to model a house through Revit AutoCAD, I saw many different things in my classmates, such as how they dealt with challenges of the modeling software and how they overcame those challenges. While working, we learned some fun things about Revit, like how to orient doors and windows and to put them where we want, as well as simulating different types of furniture in the house. Throughout the first lesson, we also learned how to manually add annotations, as well as visual dimensions and specifications for the final product. One of the biggest hurdles I faced was understanding the software itself. When starting out using Revit, it took me a while to get comfortable with the interface. I had spent a lot of time having the teacher help me practicing before I was comfortably able to model the floor plan. Another challenge was ensuring the accuracy of my measurements in the design. Some things were too big and other things were too small. It was easy to make those mistakes when inputting those dimensions or placing objects, which could really impact the final design. I had to double check my work and adjust as I needed as I was going. But despite these challenges, I found the process of modeling the floor plan to be incredibly rewarding. Later in the year, we did take a field trip to the Autoval factory in Nampa. Um, the BIM modeling in architecture has revolutionized the way that we think about construction progress. One of the most important features is the ability to incorporate and interpret the values of beliefs and workers involved in the project. By doing so, BIM modeling ensures the final project is not just a functional building, but a space that reflects the needs and desires of its occupants. Through BIM modeling, architects and builders can consider the unique perspectives of each worker involved in the project. This includes everything from individual design preferences to cultural and religious beliefs. By doing so, they can create a space that is both functional and reflective of the diversity of the people who will use it. BIM modeling also allows for better communication and collaboration between workers. By incorporating their values into the design process, everyone feels more invested in the project and is more likely to work together towards a common goal. This can lead to more efficient and effective construction process as well as a better final product. Overall, BIM modeling is an essential tool for architects and builders who want to create spaces that truly meet the needs and desires of their occupants. In conclusion, BIM is a powerful tool that has revolutionized the way architects design and construct buildings. Its applications in modern architecture are vast, from improving efficiency in project management to enhancing collaboration between different stakeholders. By allowing for real-time updates and seamless communication, BIM helps architects to create more accurate and sustainable designs, while also reducing errors and costs. Ultimately, BIM has become an essential tool for architects looking to stay competitive in this rapidly evolving industry. Throughout my research project, I learned that BIM modeling is a digital representation of a building's physical and functional characteristics. BIM is used to improve the design, construction, and operation of buildings. It also allows architects, engineers, and contractors and owners to collaborate and share information throughout the building process. Also, it can help reduce errors and increase efficiency in the construction progress. Overall, my research project helped me to gain better understanding of the benefits of BIM modeling in modern architecture.